Okay, what's going on, guys? Let me just set this up for a second. All right, perfect. All right, so today what we're going to do is we're going to go over climate variables. It's the PowerPoint I just uploaded onto the Google Classroom. Um, so we're done with the actual weather systems. Now we're going to show basically how the climate around the world affects that. So really quick, when we're talking about climate, it's the overall, okay? So climate is the overall weather conditions let me just make sure I'm in the frame. Conditions over long period of time. Okay, so what that means is our weather is a lot different. So right now it's sunny out, okay? But tomorrow it could be raining, then it could be sunny again, then it could be raining. Weather is always changing, but climate is the overall weather conditions over a long period of time. So what that means is for us where we live, we usually know that during the wintertime it's going to be colder, during the summertime it's going to be warmer. Whereas if you lived over in Florida, it's relatively warmer than it is in New York, okay? So that's when we're talking about with climate. Now, if you lived in the North Pole year round, you would just know that it's going to be a lot colder up there because the climate is Arctic, okay? So that's pretty much what the climate is. It's what you know the weather's going to be year round. Okay, so there are 8 different things that affect our climate, okay? So I'm going to erase this just so I have a little bit more room. But one of the general things that affects our climate is our latitude and our temperature, okay? So for number 1, latitude and temperature, okay? Basically what that means is that temperature is affected by the latitude. It's the angle of insolation and intensity and duration of the sunlight. So if you lived on the equator, and we're going to pretty much draw this out. So here is our side view of Earth, okay? So we have the North Pole and we have the South Pole. Now, again, it's not going to be drawn to scale. But let's say the sun is out here. Okay? So the sunlight is going to hit the Earth at different angles. So if we were going to make the sunlight, we have it hitting here. We have it hitting here. We have it hitting here, here, and here. Okay? So we're actually looking at the angle at which the sunlight is hitting Earth directly. So where it's hitting it spot on is actually located right here. So right here is actually the equator. So that's why the equator is a lot warmer than places like the North Pole and the South Pole, because the angle of sunlight hitting it is a lot greater than in the North and South Pole areas, okay? So as we go up, so since we live over at 41 degrees, we're over in this area. So our angle is not as great as the equator. So that's why we have cooler temperatures than if you lived in the tropics over in the equator. And that all has to deal with our angle from the sun, where we are in our latitude, okay? The closer down we get, so if we lived over here, this could be Florida. Now, since Florida is closer to the equator, it's going to be a lot warmer. And the reason behind that is all have to deal with the angle that sunlight is hitting us, okay? More direct sunlight, you're going to have a warmer environment, a warmer climate. So that's the first part. Now, the second part is prevailing winds, okay? So we have latitude and temperature. Now we have prevailing winds. Now, prevailing winds is the movement of air over the Earth's surface that blows from the same direction. Prevailing winds are caused by pressure differences and redistribution of heat. Okay? So remember, air always wants to go from high to low pressure systems. And with that, it's carrying different types, different temperatures of air. So that goes back into our Earth Science reference table. So if I can grab that, see if I have one on me. Sorry, I should have had that out. But if we go to page 14 and we look at our prevailing winds, it's showing us which direction that the air is going. And then it also shows us what type of climate is going to be in that area. So the equator, if you're looking at it, it's telling you that it's going to be wet, okay? That's where you have most of your tropical rainforest is over near the equator. Whereas if you go to over at 30 degrees north, it's dry because a lot of the air is going out. All that water and all that moisture is going out of the atmosphere in that type of climate. So those are the first two parts. The next part, I'm going to erase this. Is latitude and moisture, okay? So we have latitude and moisture. So latitude and moisture, it varies with latitude due to the planetary winds. So like I just said, on page 14, I'm going to show you where the atmosphere in that climate area is going to be wet or if it's going to be dry. Okay, so the equator, you're going to have a wet climate. And then even in the North Pole or the South Pole, it's both going to be dry. Okay, because then if you actually look at it, so what they give you is they give you the Earth, and where you're looking at the North Pole, in the South Pole, it's showing you that the air is dropping and then it's moving out. So if it's moving out, all that water vapor is getting pushed out. So you're not going to have any water vapor, and that's why you're going to have a dry climate, okay? It's really cold and really dry. The same thing is being shown in the South Pole. Now, if you look at the equator, it gives you this line over here, and it's telling you that it's a wet climate because when you actually look at it, the wind is blowing into it. So it's blowing all that moisture into the equator, and that's where you get that wet environment that's causing the rainforest. Okay, because remember, rainforest, it's constantly raining. All that wind is going in. So it's bringing all that water vapor in. And we know about water vapor, when it starts to rise, okay, it rises up, it's going to form those clouds. And that's how you get your tropical rainforest. All right, so the next thing we're going to talk about is bodies of water. Okay, so another thing that affects our climate, and it really is specific for us, is large bodies of water. Now, oceans, seas, lakes, and bays can modify the climate regions where land masses close to a large body of water will be regulated by a slow rate of heating and cooling. So why is this important for us? Where we're located, we're surrounded by water. So this keeps us relatively cooler during the summertime and relatively warmer during the wintertime. So on the PowerPoint, it actually shows you, and we're going to be looking at this for the first time. On page number 1, it gives you the specific heat of common materials. So if you look at liquid water, the specific heat to change it is a lot higher. So it takes a lot longer to warm up and to cool down. And then we also have a picture of Long Island where it's surrounded by water. So if you go to upstate New York during the wintertime, a lot warmer upstate New York than it is before. Okay. The other thing that affects us with our climate, and again, this could be anywhere in the world, is our ocean currents. So our ocean currents also affect our climate. So we've gone over this part of our reference table, but if you go to page 4, you can actually see some of the ocean currents that affect us. So where we are, we actually have a Gulf Stream. So if you look at the map, the Gulf Stream is a warm ocean current. So we get a lot of warm water that's taken from the tropics and is brought up to Long Island. And this is kind of the reason why we get hurricanes in August, because a lot of the systems, the hurricane systems, they follow the same track. They get brought over by the currents of the ocean. And then the same thing if you looked at places like Canada, on the right side, it's showing that there's a cold current coming down. So usually waters up in North Canada are a lot cooler than around Long Island. So the next one that also affects climate is mountains and elevation. So mountains and elevation, what we're talking about is basically the higher the elevation, the colder due to the temperature decreasing. And that's when we look in our reference table, when we're increasing altitude, our temperature goes a lot lower. And this also goes with our picture of a mountain, okay? If we have a wind coming in, the wind has to go up. So as it goes up, all that water vapor starts to form a cloud. It precipitates. And this is why you usually get forest on one side, okay? And then when that wind finally gets above the mountain and comes down, you get drier air. So there's not going to be any vegetation, which basically means plant life on the other side. So one side of the mountain could be your forest, and on the other side could be very arid, all right? Not much vegetation. So that's how mountains can affect the climate. You could have one side where it's nice and you have plant life. On the other side, you can have nothing. In elevation, if you lived up here, right, this is your house, you would be a lot cooler in your environment, okay? It'd be a lot colder up here than if you lived down here or if you lived over here. If you owned a house over here, you'd probably have a lot of plant life. If you owned a house over here, you'd probably have to water your lawn a lot more because there's a lot of dry air coming down and there's no water vapor, okay? You're not going to have a lot of rain on this side of precipitation. Now, the last thing, the last two parts that have to deal with the climate is your cloud coverage, okay? So you have cloud coverage or cloud cover, and basically it's during the day, the clouds block out the sunlight. So what this means is you have your sun, you have your ground, and let's say you have a bunch of clouds. Now, because of this, you have your sunlight coming down. It's going to hit off the clouds and go up. So that heat is going to go away. It's going to go back up into space. Only some of it is going to come down and warm up the ground. So usually on a cloudy day, it's going to be a lot cooler than when there's no clouds. Now, the same thing happens. So this is during the daytime. Now, during the summertime, or I'm sorry, during the night. So I'm going to put a moon. So here's our moon. Here are the same clouds. What happens now is during the summertime, or when the sun's up, sunlight's going to come down. Only some of it's going to go through the clouds to heat up the earth. Now, during the nighttime, okay, so this is daylight. This is the night. Heat is going to escape the earth during the night. So it's going to come up off the surface of the earth and escape back into space. But because there's cloud coverage, some of it is going to be brought back into the atmosphere. Some of it is still going to escape. So that's why during the daytime or daylight, when it's cloudy, it's going to be a lot cooler during a cloudy day. Now, at nighttime, when there's clouds in the sky, it's going to be warmer because some of that escaping air that's warm is going to get trapped underneath the cloud. Okay, so that's how cloud coverage can affect your climate. Now, if you had no cloud cover, which is our last part, number 8, and I'm going to get rid of this. So our last part is no cloud cover. So we have daytime and we have nighttime. So I'm going to put the ground again. And this time I'm not going to put any clouds. So we have the sun again. And again, it's going to bring down the heat from the sun. And since there's no clouds, it's not going to get reflected back. So it's going to be a lot warmer when there's no clouds. Now, during the nighttime, that heat is going to want to escape the earth. And because there's no clouds blocking, now it can start just going back up into space. And what happens is when there's no clouds, when it's nighttime, it's going to be colder. So these are the 8 different parts that affect the climate, okay? So you have latitude and temperature, where your latitude is in respect to the sun, prevailing winds, where you're located, where those winds are going to be moving. You have your latitude and moisture, which is in your Earth Science reference table, which basically shows you where the water vapor is getting trapped on the earth. Large bodies of water. If you live by a body of water, your temperature for your climate is going to vary a lot less than if you lived in the middle of a continent. Ocean currents, depending on if you live by a warm current, you're going to have warmer waters, which is going to keep you a little bit warmer. Or if you have a colder current that's by you, you're going to have those winds from the colder water keeping your continent or your area cooler. Your mountains and elevation. So since we live pretty close to sea level, our elevation does not really affect us. But if you lived in Colorado, you would have a lot cooler of a climate. Cloud coverage and no cloud coverage, that just shows whether heat can escape or get into your area where you live. Okay? So these are the 8 different parts. Now, to review this, we have climate variable worksheet that I'm going to upload right after this video. And then we're going to go over it on Wednesday. Also, I'm thinking about planning a Zoom meeting on Friday. This way, instead of you guys just listening to me the whole time, now you guys can actually ask me questions and I can see your guys' faces instead of just talking to myself. Okay. Does anyone have any questions? And again, if you have any questions, just, you can shoot me an email, or you can message me on Remind. Okay. So I'm going to upload that worksheet right after this. I'm going to upload another PowerPoint tomorrow. Make sure you go over the PowerPoint. It will, besides just this video, it will help explain some of those questions that you're looking at. And on the back page, there's 2 different diagrams. One's a graph, and the other one is a picture of the United States with our latitude line. And it's just going to ask you 3 questions on it. Okay, so make sure you really look at this. Try to understand it, answer it the best you can, put it on Google Classroom, and then I'll look at it. Okay. All right, guys, I'll see you later.